Hello everyone, this is me Manya, student of Medical Biotech Department, Maharishi Dayanand University, Rohtak. I am here to present a topic on bioinformatics, which is dot plot method. So dot plot method is one of the alignment algorithm methods used for sequence alignment. There are basically three methods used for sequence alignment. These three methods are first dot plot method, second dynamic programming method, third word method. We will be discussing dot matrix method here. Dot matrix method is most basic sequence alignment method, also known as dot plot method or dot matrix method, developed by Gibbs and McIntyre in 1970. They have been generally employed to search for regions of high similarity in two sequences and repeats within a single sequence. A dot plot is a visual representation of the similarities between two sequences and is likely to be the oldest way of doing so. Starting with its principle, it is a graphical way of comparing two sequences in a 2D matrix. In a dot matrix, two sequences to be compared are written in the horizontal and vertical axis of the matrix, such as x and y axis of the graph. Comparison is done by scanning each residue of one sequence for similarity with all residue in the other sequence. If a residue match is found, a dot is placed within the graph, otherwise matrix position are left blank. Considering the example, here suppose we have to align these two sequences, what we will do, we will create a 2D matrix where sequence 1 is representing in the x-axis and sequence 2 being represented in the y-axis. We will fill the matrix by considering each residue of x-axis compared with each residue of y-axis, such that if two residue match each other, then a dot is placed, and if these two residues do not match each other, then the place is left blank. After completing the filling of matrix, these matrix is used to give the evaluation of the matrix is used to give the result of the sequence alignment. So there are many interpretations we can get from the graph. These are when two sequences have substantial region of similarity, then many dots line up to form contiguous diagonal lines which reveal the sequence alignment. This is the main important interpretation we get from the graph of dot plot matrix. So it says that if there is a diagonal in the graph, this indicates that the two sequences representing the x and y axis are similar. Next, if there are interruptions in the middle of diagonal line, it indicates insertion or deletions, which are indicated by gaps in the aligned sequence. Next, parallel diagonal lines within the matrix represents repetitive regions of the sequence. This we will be discussing later in the video. Now, there is a problem using dot plot matrix. What is that problem? While comparing large sequences using dot matrix method, there is high noise level. What do you mean by noise? Noise is accidental match or random chance of an identical symbol at any given position. So, in a layman language, what do you mean by noise? Noise is nothing but a large number of dots that are produced in the graph so that there is no signal that can be interpreted from the graph. In most dot plots, dots are plotted all over the graph, thus obscuring the identification of true alignment, what we call as pattern that we see from the graph, the visual representation that we get from the graph at the conclusion of the alignment. So, when there are many dots, that is, there is many noise produced from the graph, then we cannot get any conclusion from the graph. For DNA sequence, problem is particularly acute because there are only 4 possible characters in DNA, and each residue therefore has 1 in 4 chance of matching the residue in another sequence. Comparing to a protein sequence, this problem is less acute because there are 20 possible character or amino acid residues that can be substituted for protein sequencing. Now, we will be considering how to obtain the number of dots. Number of dots can be obtained by this formula, which is equals to number of probability pair into the length of sequence 1 and sequence 2. While comparing one nucleotide for sequence length of 20 and 18, number of dots are 25%, which is obtained as the probability of occurrence of one nucleotide is 1 by 4, which is 25% into 20 and 90, which gives 90 dots. While comparing binucleotide, number of dots are, since the probability of occurrence of binucleotide is 1 by 4 into 1 by 4, which is 1 by 16, that is equals to 6.25%. So, as you see, while comparing binucleotide, the probability of occurring of binucleotide reduces, which in turn reduces the number of dots it will produce. So, looking at this graph, we see here W equals to 1 represents we are using one nucleotide for dot plot method comparison, sequence comparison, and as we see there are many dots produced, so much noise is produced from this graph that we cannot get any conclusion as no particular signal is observed from the graph. But when two nucleotides are used, there are many dots, but though these dots are comparatively less when compared with a single nucleotide. As we increase the number of nucleotides further, we see the number of dots keep on decreasing. And when the 6 nucleotides are used, we see the number of dots are reduced so significantly that a visible pattern is easily observed, and we can easily interpret the graph and get the conclusion of two sequences being compared. So, the improvement of dot plot method is to lower signal to noise ratio. Word method is used, as we have seen, by using 6 nucleotide oligomers. When oligomers are used, the number of dots they produce is reduced, which give a particular pattern of the graph, which helps to conclude the result. Here, instead of using single residue to scan for similarity, a filtering technique. Here, it's important, a filtering technique has to be applied, which uses a window of fixed length covering a stretch of residue pairs. So, there are 3 most important terms in window technique. The first is window size, second is stringency, and the third is mismatch limit. So, window size is a number of bases that is considered and compared to generate a single data point on the plot. Stringency, on the other hand, is the minimum number of nucleotides in the window that must match so that a dot can be placed. While mismatch limit is how similar two sequences in a window must be considered a match. Consider this example. Here we have taken build up a 2D matrix. We have to build a 2D matrix using window technique. So suppose we have taken the window size of 3 and we have taken mismatch limit as 1. So in window technique, what do you mean by these 3 terms? That we have taken window size of 3 and mismatch limit 1 represents the up to 1 nucleotide base in a 3 base window can be considered as a match. So we compare these 3 window with the y-axis window, and when there is a significant match, we place a dot over there. Now we will slide this window and similarly operate and will give the result of our analysis. Now we will consider the various patterns which are obtained from this dot plot method graph. Now when contiguous main diagonal, this represents perfect similarity between two sequences. When small parallel lines to main diagonal, it represents repeated regions in same leading direction on different part of sequence, which represents duplication, as shown in figure B. Now, palindrome sequence, which is indicated by line perpendicular to main diagonal, as shown in figure C. Transposable elements are shown as figured in D by partial palindrome sequences. When there is a block on main diagonal, it indicates repetition of some symbols in both sequences. This indicates presence of microsatellite, which are repeated DNA sequences, as shown in figure E. Comparatively to E figure F shows some parallel lines that indicate tandem repeats of larger motif in both sequences. This is indicated as mini satellite pattern. So, you can distinguish between mini satellite and microsatellites by a block and few parallel lines. Now, this graph in G figure shows main diagonal is discontinuous, which indicates that two sequences share a common ancestor. Figure H shows partial deletion in sequence 1 and insertion in sequence 2. There is deletion in sequence 1 and there is insertion in sequence H. Now we will consider uses of dot plot method. Dot plot method is mainly used to align two proteins or to align two nucleic acid sequences. It is used to find self-base pairing of tRNA by comparing to a sequence to its self-complemented and reverse. That is, it is useful in identifying secondary structure through self-complementarity of genome. Lastly, the most important one, it has some applications in genomics where it is used in identifying chromosomal repeats and in comparing gene order conservation between two closely related genomes. Now, everything has its own limitations, so does dot plot method. Few of its limitations are dot plot method is a visual analysis method, thus lacks statistical rigor in assessing the quality of alignment. Next, this method is restricted to pairwise alignment. It is very difficult for the method to scale up to multiple alignment due to its time consuming and so much effort is needed to apply dot plot method for multiple sequence alignment. Therefore, it is basically used for pairwise sequence alignment. There are various web services that provide pairwise sequence comparison using dot plot method. These are Dot Matcher, Dot Dotix, and Matrix Plot. That's all. Thank you.